Okay, hey. R4 is equal to area 1 plus area 2 plus area 3 plus area 4. Oh yeah, this is f of x, x squared. Okay, area 1 has a width of a fourth times a height of 1/4 squared. Area 2 is a fourth, the width of a fourth times 2/4 squared. Okay, so then a fourth and 3/4 squared. And now area 4, a width of a fourth again, and a height of 4/4 squared. Oops. We can factor out the fourth. 1/4, 1/4, 1/4, 1/4. Factor that guy out. And use exponents now. We have 1 squared over 4 squared. Plus 2 squared over 4 squared. Plus 3 squared over 4 squared. Plus 4 squared over 4 squared. Let's get this thing out of there. Okay, now notice that we can factor out a 1/4 squared out of this whole thing. Okay, now we could take this a little further and say this is 1/4 cubed times 4 times 4 plus 1, 2 times 4 plus 1 over 6. This is formula 2-2. This is formula 2-2. 1 squared plus 2 squared plus 3 squared plus 4 squared. Remember that formula looks something like this. So we're using that formula there. Going up to n, we do this. Well, what's n in this case? It's 4, so we put 4 in there. We have this guy. Okay, so that was step 1. Now step 2, we want to generalize. Okay, so the key for generalizing, now notice this 4 is that 4 there, and it's that 4 there. So our n, we're going to have 1/N cubed times 1 squared plus 2 squared plus 3 squared plus up to N squared. So using that formula that I just erased, we have 1/N cubed times n times n plus 1 times 2n plus 1 all over 6. Like so. All right, that's step 2. Rn is that funny looking thing. Okay, now think about what this is giving you. This is a formula for Rn for any n. So if you wanted to compute R100, you put a 100 in for n and you'd get the answer. So now, the definition says that this thing is the limit as n approaches infinity of Rn. And so we're just going to take the limit as n approaches infinity of this thing. Now you might say, okay, this looks really difficult to take the limit of. Now you might want to do some algebra to get this into a polynomial over a polynomial. Okay, so let's do that. Okay, so let's multiply these things through. Let's see, that's so taking care of the top, we got n times, let's see, we got 2n squared there, n times that, plus n plus 2n plus 1. N and 2n give us a 3n. That, multiplying the n through, we have 2n cubed plus 3n squared plus n. Okay, so here I multiplied out the top. So this thing is 2n cubed plus 3n squared plus n all over 6n cubed. This is capital, whoops, capital Rn. Alright, now we take the limit as n gets huge. And notice that as n approaches infinity, this thing gets, the top gets large and the bottom gets large. So we have infinity over infinity. Doesn't make sense to us. Go ahead and use L'Hopital's rule. Let's see, we got 6n squared plus 6n plus 1 over 18n squared. Again, you plug it in. Doesn't make sense to us. Use L'Hopital's rule again. We've got 12n plus 6, 36n. Again, infinity over infinity. Use L'Hopital's rule. Over 36. Now, as n gets large at 12 over 36, we get 12 over 36. 12, 24 over 36, that makes 1/3. So this is our answer.